Everyone, welcome to the lecture series on importance of mathematics towards engineering. In today's discussion, we are going to talk about differential calculus in dynamics. So already we were talking in the previous session about differential calculus and its importance towards engineering. In that series, today we are going to further talk about the importance of differential equations when it comes to dynamics. First of all, so which are the areas, which are the places where we need differential calculus? Actually, if you see, uh, first of all, where the force is involved, that is when we talk about velocity, when you talk about acceleration. So when the force is involved and when there is some rate of change, that is displacement with respect to time or change of rate of change of something with respect to an independent variable, we come across differential calculus. That is, acceleration is a derivative of velocity. Similarly, the force is the rate of change of momentum. So it follows some physical laws. So differential equations plays a very important role in mechanical engineering. For example, just we saw it is important in kinematics and in many important areas of mechanical engineering. So in this series, the very important concept is mathematical modeling, that is describing the system behavior using mathematical modeling, where we come across various differential equations. The real time situation of a mathematical connected mechanical system is converted into differential equations with some governing conditions, where we work with equations and we try to find solutions. So in this regard, we use the ordinary differential equations and also partial differential equations. Ordinary differential equations are of importance when we talk about one independent variable, and when we talk about partial differential equation, it is used when we come across more than one independent variable. The very important areas of differential calculus are when we talk about springs and rate of change and dampers and oscillators, which is used in mechanical apparatus. And we try to predict some system response by the methodology. We have various methodologies given by Legendre, Euler, Cauchy's method of solving the differential equations. So using the ideas given by them, we can carry out various mathematical procedures, and we can find out the solution of such mechanical related systems. So we can predict solutions, we can interpret results, and we can go for further improvement in the apparatus required. So that is the very important fundamental thing why we more insist on differential equations, because it is a very important tool when it comes to mechanical engineering, where it is and further, if you see, differential calculus is very important when you come to the topic of stress and strain. So stress and strain, for example, if a material undergoes deformation, strain is involved. So there is a relationship between stress and strain. So it is very important to understand the relation, to understand the behavior under load structures. So in structural analysis, predicting material failure and the strength of such kind of situations apparatus, so we use the concept of differential calculus. So it is recommended for researchers to practice more on differential calculus while they start working with stress and strain, when they talk about materials, when they work with problems related to materials in mechanical engineering, and also in various areas where you come across the stress and strain concepts, where we can tell like strain can be derived as a derivative of displacement, so and we can connect with stress and we can understand the behavior. So all these things can be done. Thank you for listening. Thank you.